Go over a crash course on inverses and composition. And honestly, I was a little too easy on us during the school year for composition, so I've put some harder ones in here as well as some extra practice ones as well. So just as a friendly reminder, composition is when we're kind of doing like substitution, right? We have f of g of x. So we're taking a function and substituting it into another one. There are two main ways of writing it. I have those ones highlighted. Doing f of g of x does not equal g of f of x. That's what this colorful example is saying up here. I'll let you kind of read through that. Things we have to pay attention to are domains. So I think earlier in the school year, the way that I described it to you is what is right here, which is that the domain of this new composition is always going to be the domain of the inside function. So that's what g is, the inside one, the one that we're substituting inside of f. And then whatever the new function is. So that's going to be the entirety thing, g of f of g of x. So we kind of combine those and take the most restrictive version of both of those. And you'll see what I mean as we do some of the examples. So let's just start off with a not super crazy difficult one. So here's a table with x values, f of x, and g of x values. So we're going to start off with f of 1. So I'm going to find the x value of 1, and f of 1 is going to equal 3. So this inside bit here is actually a 3. And now it's asking me, what is f of 3? So I do the same exact idea. I go find the x value of 3, and I say, hey, f of 3 is going to be -1. And that's going to be that value. Similarly, that was a really hard word for some reason. I'm going to do f of 2, so I'm going to find the x value of 2, and that's going to be 1. So this is saying what is g of 1. So now I'm looking at g, so I have to be really careful about that. G of 1, so I go to the x value of 1, and I'm going to the g value, which is going to be 0. So g of f of 2 is going to equal 0. So let's do this last one here. So this one is crazy, and I'm hoping I set it up right when I made it. So I'm going to do g of -1. So I'm going to look right here, and g of -1 is going to be 0. So I'm going to have the g out there that I didn't touch, that g that I didn't touch, and then this inside g of -1, that's 0. Now I'll jump out here. I'll use this pink, which is not going to show up very well, but that says g of 0. So I'm going to look at the x value 0 and what g of 0 is. So that's going to be a 1. So I have this g on the outside that I haven't touched, and then this pink highlighter is 1. And now this is asking me what is g of 1, and we've already done that. We are going to get 0. So that's just like a fun way of practicing doing those things. All right. Now we get to some of the harder ones. And the reason they're harder is just because the functions themselves are a little bit harder. So when we substitute these things in doing the composition, we're going to end up with fractions inside of fractions, and we don't really love that. So it's asking me to do f of g of x and then state the domain of this new function. So let's super quickly, let's remind ourselves that the domain of f would be -3 and that the domain of g is that x cannot equal 2. To figure out what f of g of x is, I'm going to do f of g of x, which is x over x minus 2. And then everywhere that there is an x inside of f, I'm going to substitute this entire thing. Okay, so I'm going to have 1 over, and then everything that's there, x over x minus 2, and then plus 3. And we don't like leaving in this state because we don't love fractions inside of fractions, mainly because of some dude 500 years ago who said we don't like it. It's probably longer than 500 years ago, but... So two main ways of doing this. You can either do keep, change, flip by first making the bottom one fraction. So we would do that by multiplying this by x over x minus 2 over x minus 2. That's going to give us 1 over a common denominator here of x minus 2. And then we can keep the first fraction, which is 1, flip the sign to multiplication. Wait, keep, change, flip. Whoa, gosh, I don't even know what I just typed in there. Oh my gosh, I forgot to do math there for a second. Change, it's not letting me erase, okay. Keep the first one, change the sign of multiplication, flip the second one. So we would end up with 1 times, and then x minus 2 over an x plus a 3x minus 2. And then we would just clean this up. So we would get x minus 2 over, this is going to be 3x plus the x, 4x minus 6. And now this is what f of g of x is. And so when it comes time to its new domain, So we're setting the bottom equal to 0, saying that can't equal 0. We're going to get that x cannot equal 3/2 when we simplify it. But we have to hold on to this domain because at some point we had an x minus 2 in the bottom, which means that we have to add this over here and say, hey, x is also not going to be able to equal 2 because this thing was an x over an x minus 2 at some point in its lifetime. We don't have to worry about the f because it never was a 1 over x plus 3. It was always something different because f was always changed from f of x to be f of g. It wasn't f of x ever in its lifetime here. And so that would be our new domain. Now, I mentioned there's another way of doing this. It's the way that I would prefer to do it, so I'm just going to rewrite this. And it's how I taught you to do things, most likely, which is that we multiply by the least common denominator of both the top and the bottom. And that is just going to cancel out this fraction over here, and we're going to get 3 times x minus 2. And so we end up getting this process right here, just in a different way. I personally think it's faster and cleaner, but that's just my preference. All right, so this is just going to be more practice doing the exact same thing because I wanted you to have some more practice with some of these harder ones. I'm going to leave them for you right now and not put the answers up, and we can go over them together. All right, inverses. All right, there's a lot of stuff about inverses. Here's just some stuff we care about. We have, that's the notation, F inverse. So we have that, the line of reflection over a original graph, and the inverse is always y equals x. And if something passes this horizontal line test, then we know that the inverse is a function. So we use the original graph, and if the horizontal line test passes, then the inverse is going to be a function. So like right here, the inverse of this one, not a function. This one is. If both the original and the inverses are functions, we refer to them as one-to-one, which means that each x has one y and each y has one x. And because of that, we have something like 1, 3 in the original one, so inside f. Then in the inverse, we actually know that we can have 3, 1. And that's because the x's and the y's flip when we switch back and forth, which is exactly what property we're going to use here. So we're going to ignore that typo from when I changed the question. This just says find, let f be 1-to-1. That means that each x goes with one y and each y goes with one x. And this is f. So that's important for us to know that this is what f is. So when it says f of 10, we just look for the x value of 10, and that's going to be 19. Easy peasy. Now, when it says f inverse, okay, and this is saying that x equals 2 in the inverse, okay, so in the inverse, we're doing this, 2 comma something, in the inverse, super important. That means that in the original, this is asking us for something comma 2. So we just look up here and we say, hey, look at this one has a y value of 2. That means that this little blank here has to be -3. So f inverse of 2 is going to be -3. And again, that's just because of the way that these things work, that each x goes with one y. So when we flip-flop them, then they're going to flip just like this. This one, we have f of 4. So here's an x value of 4. So this is just going to equal 5. That's easy. This one is basically saying in the original f, okay, we're looking for something that has a y value that is 4. Because in the inverse, this is the x value. And when we switch, it becomes the y value. So I just come over here and I say, hey, look at this guy right here. So this thing is a 7 is what we're missing. I swear I changed the color to red, but it did not want me to do that apparently. So long and short of it, right, the original is talking about x values, and when it's doing inverses, it's kind of like the y values of the original. And that has to do with this exact process right here, which is how we find inverses. We flip-flop x and y, and then we resolve for what y is. And that can get a little complicated sometimes, so that's why, again, I've given us some extra examples down here. So I'm going to flip x and y, and then my goal is going to be to get y by itself. So I don't love that y is in the bottom. I'm going to multiply that to the other side. I'm going to distribute that x through. That's because I don't like that the y is now trapped inside parentheses. Next thing is I'm going to try to get the y's to be on one side of the equation. There are multiple ways of doing this. I'm going to choose to subtract the 2y and add the x. You can also choose to have a negative x equals 2y minus xy. It's perfectly fine. I'll show both ways. we're going to factor out a y and have x minus 2 equals x, y times x minus 2 equals x. And then once we get the y by itself, by dividing the x minus 2, we say, hey, this is the inverse. Now, over here, you're going to get the exact same thing, except you're just going to have a negative x here, and you're also going to have this. So if we had done it that way, we would have just gotten that. They're the same thing. If you factor out a negative from the bottom of this second one over here, it'll cancel out with the x on the top and flip-flop things around. So it could work. Now they're asking for the domain and range of both. So let's talk about the domain of the original one. That's going to be x cannot equal 1. And that translates to the range of the inverse. So y will not equal 1. And that's because we switch x and y. So in the original, if x can equal 1, then when we flip x and y, that's now going to say y can equal 1. And since we're much easier to find domain, we'll find domain of the inverse now. That's going to say that x cannot equal 2, and that will translate to the range of the original one. And that's a huge property to understand, that the domain of the original becomes the range of the inverse, and the domain of the inverse becomes the range of the original. That's like our number one way of finding range until we start getting better and better at working with functions and figuring out different things about them. Alrighty? So at this point, if you feel like you're good, you don't need to keep watching, but I'm just going to run through these two examples, and maybe I'll go back up and do the two that I skipped just so that they are done. So I'm going to flip-flop x and y. This one looks like it's going to be a little bit more complicated, but same exact process. Don't love that that y is in the bottom, so I'm going to multiply it to the other side. Don't love that it is trapped in parentheses, so I'm going to distribute the x through so I don't have to have those parentheses. And now I'm going to group the y's on one side. So I'm going to subtract the solitary y, and I'm going to add the 5x to the other side and factor out. So I get 2x minus 1 equals to 5x plus 3, and then I will divide. And once I get it by itself, then I label it as the inverse, y inverse. And we have that. So let's do our domain of the original one is going to be that x cannot equal 5/2. So I'm just setting the bottom equal to 0. That's going to be the range of the inverse. So y cannot equal 5/2. Make sure you flip the letters when you're doing this. And now I'm going to do domain of the inverse is going to be that x cannot equal 1/2, which is going to become the range of the original. So it's really just algebra skills at this point, where we're just kind of going through the motions, right? So I got x equals 2y minus 3 over y plus 6, and it's, you guessed it, the exact same process. Are you bored of it yet? If you are, that's a good thing. That means that you're feeling really good about this and you know exactly what you're doing. Let's see. I don't see any great way of doing this. I think I'm going to add the 3x and subtract the xy. That was just to kind of keep things positive. You don't have to do it that way. And everything's going to be a little bit backwards now when I'm doing this, so I will ultimately flip-flop it right now. I'll have 6x plus 3. That is factorable. I should be careful about whether I can simplify anything. I don't think I can right now. If you flipped it the other way, you would end up with a negative 6x minus 3 over an x minus 2. So it'd be perfectly fine if you did that. Domain of the original, x cannot equal negative 6. That's the range of the inverse. And then we have domain of the inverse, x cannot equal 2, which is going to be the range. There we go. Now I gotta go back and do those hard looking ones up here. They're just like a lot of effort in simplifying, right? All right, f of g. So I'm doing f of x plus 4 over x minus 4. Do not try to simplify that any further. You will not have a good time if you do. And now the x that's in f, so this little x right here, I'm replacing with what g is. That gives me this whole thing. I'm going to choose to multiply by the x minus 4, top and bottom, which will give me 2x minus 8 all over, and x plus 4, the fraction would cancel there, minus, and now I'm multiplying these together. I'm going to distribute that as I go as a bit of a time saver there for myself. Let's see, I'm feeling like I shouldn't have actually distributed the 2 because I think things are going to simplify a little bit here. I'm going to get a negative 4x plus 24, and everything is divisible by 2, so I can simplify this to x minus 4 over negative 2x plus 12. That's going to do it. That's what f of g of x is. And when I go to do my domain, I'm going to hold on to the domain that x cannot equal 4, coming from the g of x, and then whatever this new domain is over here, which is going to be that x cannot equal 6, I believe. So my overall domain is that x cannot equal 4 or 6. And if I mess any of these up, please drop it in the comments so other people can look at it and see, that they're doing it fine and that I just goofed while trying to do math really quick. Ooh, this one's annoying because I got x in 2 places. So I got to do 5 over x over a 5 over x plus 2. But that's not that bad because we're going to multiply top and bottom by x. That's going to cancel the fraction. We're left with 5, and then 5 plus 2x. So we're already done with that one. That was a breeze. And we're going to capture the domain of this guy, x cannot equal 0, and capture the domain of this, which is going to be negative 5/2. So there's the new composition, and there is the new domain. Hopefully you found this little crash course helpful, and I will see you in the next one. Bye!